My dear students, let me welcome you all to the General Revision edition of Physics. In this edition, you will be encountered with miscellaneous questions. Questions that cover most of the curriculum. Hopefully, you'll find them interesting and useful. So let's get started. Mention an application of each of the following. Application on mutual induction. Yes, thank you very much. Transformer and induction coil. Okay. Application on self-induction. Yes, right. Fluorescent lamps. Application on dual nature of electrons. Electrons behave as particle and as wave. Of course, electron microscope. Application on eddy currents. It's so easy. It is, yes, induction furnaces. And application on spontaneous emission. Okay, spontaneous emission is a feature that occurs in traditional sources of light. And application on stimulated emission, yes, laser. And application on photoelectric effect. I believe it's all easy. It is taken from the, yes, the title itself. It is the photoelectric cell or photocell. Application on electromagnetic induction, it is the dynamo. And application on magnetic torque or magnetic effect of the electric current. As a matter of fact, we've got 5 devices that are based on magnetic torque. Yes, first of all, motor, moving coil galvanometer, DC ammeter, DC voltmeter, and ohmmeter. Okay, any one of them will do. Application on thermionic emission. Yes, this is very important. It is the cathode ray tube. And application on thermal effect of the electric current. Yes, it is the hot wire ammeter. Hot wire ammeter. And now we've got another type of questions. What is the scientific idea on which the function of each of the following devices based? We want the scientific idea. Scientific idea of logic gates. What about the idea of logic gates? Okay. Performing logic operations such as inversion, and this takes place in the NOT gate, simultaneity and coincidence in the AND, and optionality in the OR gate. And what about the idea of extrinsic semiconductors? Okay, your attention please. Conductivity of a semiconductor is increased when doped with certain impurities. And what is the effect of impurities? Impurities increase the number of charge carriers in the semiconductor. Okay, so the effect of impurities, okay, it increases or they increase the number of charge carriers. And what about the idea of the holography? As a matter of fact, hologram is based on the idea that the reference beam, and what about the reference beam? It is coherent and monochromatic light, interferes with the object beam. So the difference in phase and the difference, yes, in intensity are recorded. We managed to record the difference in phase between the rays coming from the object as well as the difference in intensity. Are recorded in the holographic plate, and a 3-dimensional image is obtained. Idea of the PN junction. PN junction as a rectifier. Okay, this is very important. Okay, PN junction permits the passage of the AC current, alternating current, during the halves in which the crystal is forward biased and prevents its passage, prevents the passage of the current during the opposite bias, during the reverse bias. Okay, so it can act as a switch. And what about the idea of the transistor as a binary device? Transistor as a binary device. Okay, the circuit of a transistor can have two states, off and on, so it can be used as a binary device. A binary device, a binary system, is a digital system based on only two digits, 0 and 1. And we want the idea of the resonance circuits. What about the idea of the resonant circuits? Since the inductance causes the current to lag behind the voltage and the capacitance causes the current to lead on the voltage, therefore they can be adjusted to cancel the effect of each other by changing the capacitance of the capacitor or inductance of the coil. The resonance frequency is changed to be equal to the frequency of that of the desired wave. At resonance, the current is at its peak value and the impedance is at its minimum value. Z is equal to R. At resonance, VL equals VC, XL equals XC, V supply equals voltage applied across the resistor. The impedance is equal to the resistance. V and I are in phase, that's to say the phase angle is equal to 0. And finally, what about the idea of the oscillating circuits? The oscillating circuit consists of an inductive coil and a capacitor connected together via a switch, okay, as shown in the figure. In oscillating circuits, exchange of energy occurs between a coil which stores magnetic energy and a capacitor which stores electrical energy. So in oscillating circuits, exchange of energy occurs between a coil which stores magnetic energy and a capacitor which stores electrical energy. Now we've got another type of questions. Mention one use of each of the following. Mention one use of each of the following. Laser in medicine. What about the use of laser in medicine? Okay, just one use. Laser can be used as cutting or welding tool in delicate eye surgery. Okay, one use of laser in military field. Laser has military applications such as aiming and guidance of missiles and smart bombs. Aiming and guidance of missiles and smart bombs. Use of X-rays in industry. X-rays are used to check defects in metallic structures because X-rays have high penetrating powers. Use of photocells. Okay, photocells convert light energy into electric energy. Use of thermal imaging in tomography, embryology, criminology, okay, and night vision. And we want, yes, just one use or application of veins displacement law. Okay, we can use it to determine the temperature of a black body. Another different type of questions. What is the function of oscillating circuits and resonant circuits? Okay, let's start with oscillating circuits, talking about the function of oscillating circuits. Oscillating circuits are used to transmit electromagnetic signals. Resonant circuits are used to pick up certain waves, used to pick up electromagnetic signals. And another type of questions, explain how to eliminate the effect of the atmospheric temperature on the expansion of the resistance wire of the hot wire emitter. Explain how to calibrate the hot wire emitter. Okay, let's start with the elimination of the effect of the atmospheric temperature on the expansion of the resistance wire in the hot wire emitter. To eliminate this effect, the resistance wire is mounted, is placed on a plate made of platinum iridium or any metal having the same expansivity. Thus, the wire and the plate expand equally, keeping the wire with the same tension. And how to calibrate the hot wire emitter? Okay, hot wire emitter is calibrated by connecting it in series to a moving coil galvanometer. Another type of questions, an AC supply of variable frequencies connected to a pure inductor and hot wire emitter. So we've got AC supply of variable frequency and it is connected to pure inductor and hot wire emitter. What happens to the reading on the emitter? When a soft iron core is inserted inside the coil, okay, what happens to the reading on the emitter when the frequency of the source is decreased? Okay, first of all, we will take it, what would happen if, yes, an iron core is inserted inside the coil. It decreases. The current decreases. Why? Because inductance increases. So XL increases. XL is some sort of, yes, opposition. XL equals 2 pi FL. L is increased, so XL is increased, so the current decreases. So the reading decreases. And what about what would happen if the frequency is decreased? As a matter of fact, it is unchanged. It remains unchanged. Another type of questions mention only one factor that affects each of the following. We just want one factor that affects the work function. Okay, this is very important. Yes, it depends only on kind of the photosensitive source. So the factor is kind of the photosensitive source, kind of material. Factor that affects intensity of photoelectric current, intensity of the photoelectric current. Of course, yes, it is affected by the intensity of the incident radiation. Factor, just one factor that affects the wavelength at which the intensity of the radiation of a black body is a maximum. What is the factor? Of course, it is the temperature. Okay? The temperature is the only factor. So absolute temperature of the black body. And we want one factor that affects the wavelengths of the continuous spectrum of X-rays. Of course, the potential difference between the anode and cathode. And one factor that determines the energy of the photons emitted from college tube. Okay, also it is the potential difference between the anode and the cathode. And one factor that affects the wavelengths of the line spectrum of X-ray. As a matter of fact, it depends only on kind of material of the target. And now we've got another type of questions. Write the scientific term. Evacuated tubes which operate on thermionic emission and are used as monitors in TVs and computers. It is cathode ray tube. Cathode ray tube. Detection of infrared radiation emitted from an object. Detection of infrared radiation emitted from an object. Yes, it is thermal remote sensing. Emission of a photon under the effect of another photon, such that the emitted photon is in every way identical to the stimulating photon. Your attention to the word stimulating photon. So it must be a stimulated emission. Okay. Imparting of energy to the active medium to excite it. Okay, this occurs in laser. Giving energy to excite the active medium, we call it what? Okay, we call this pumping process. Okay, another scientific term. The product of the free negative, denoted by small n, and positive, yes, concentration, denoted by P, is a constant. And what about this constant? Is independent of the amount of donors and acceptors. What is this? It is mass action law. Okay, great. And now we want a definition, scientific term, the attraction force or attractive force which attracts the free electrons in the surface of a metal to the interior of the metal. Okay, this we call it surface barrier potential. So it is surface barrier potential. Okay, and now we've got something important. Semiconductor devices, which are based on inner photoelectric effect. They are sensitive to environmental conditions such as light, heat, pressure, humidity, radiation, and chemical pollution. So they are used as sensors. What about them? They are, yes, optoelectronics. They are optoelectronics. A method of improving visibility of objects in a dark environment by detecting objects' infrared radiation and creating an image based on that information. Yes, it is thermal imaging. And another scientific term, okay, the magnetic flux, which induces an EMF of 1 volt in a single turn coil made of just 1 turn, when the flux is reduced to 0 in 1 second. We call this, yes, Weber. Magnetic flux density of a uniform magnetic field, which produces a force of 1 Newton on a wire of 1 meter in length, carrying a current of 1 ampere, when the wire is placed perpendicular to the field. Of course, this is, it's all easy, it is the Tesla. And another term, the instantaneous EMF induced in the coil of an AC dynamo when the plane of the coil makes an angle 45 with the field lines. What about this instantaneous EMF? At this particular moment, it will be equal to the effective value of the induced EMF. And now we've got very important type of questions. Okay, what happens when? First of all, the 2 metallic rings in an AC dynamo are replaced with a split cylinder commutator. Okay, the AC current becomes unidirectional varying current. So the AC current becomes unidirectional varying current. Yes, it has just one direction, but it's still changing. It is varying. Okay. So the AC current becomes unidirectional varying current. What happens when the shunt in an ammeter is replaced with another shunt of lower resistance? Okay, this is very important. And we'll make it easier for you with respect to the sensitivity of the ammeter and the maximum current that the ammeter can measure. Okay, thank you very much. Sensitivity of the meter decreases. Sensitivity decreases means the device can measure greater current intensities. So sensitivity decreases and the device, the meter, can read greater current intensities. What happens? Yes, what will happen to the reading on the hot wire emitter in the shown circuit when the key is closed? Okay, key is closed it means yes, another capacitor connected in parallel is connected, okay, to the circuit. Okay, so it's all easy. When connecting capacitors in parallel, capacity increases, okay, and what happens to the capacitive reactance? Capacitive reactance decreases, XC equals 1 over 2 pi FC. So the current, yes, so the current increases. We've got another circuit, and this is very important. And you're asked what will happen to the reading on the voltmeter in the circuit shown when the value of the variable resistance S is increased. Your attention, please. The voltmeter here measures what? It measures not the terminal voltage, it measures the voltage applied across the resistance R. So what would happen when S is increased? Yes, the current flowing through the circuit is decreased, and voltage applied across R depends on the current, so it will decrease. The reading on the voltmeter decreases. What happens when the key in the circuit shown is open? It's already closed and it is open. This is the experiment usually used to demonstrate self-induction. Okay, so what happens when the key is opened? Yes, and we want you to account to justify your answer. Thank you very much. The lamp momentarily flashes due to the high forward EMF induced by self-induction. What happens when the switch, yes, key in the circuit is closed? Okay, first of all, let's discuss the readings on the two voltmeters, V1 and V2. The voltmeter V1 located on the cell measures terminal voltage. And when the switch is open, it reads its maximum. It reads, yes, EMF of the cell. So right now, V1 is maximum. And what about V2? V2 equals 0. Why? Because it is the voltage across R2, and it depends on the current. Circuit is open. So right now, before closing the switch, V1 is maximum. It is terminal voltage. V2 is 0. So what happens when closing? Maximum will be decreased, of course. So V1 decreases, but V2 increases. V1 decreases, but V2 increases. V2 increases because current will flow, okay? And V1 decreases because right now the reading on V1 will be equal to terminal voltage, not the EMF. What are the conditions necessary for ejecting electrons from the surface of a metal with a particular electromagnetic radiation? Okay, to eject electrons from the surface of a photosensitive surface, it has something to do with the frequency. Okay, thank you very much. The frequency of the electromagnetic radiation should be greater than the critical frequency or threshold frequency. We call it critical frequency or threshold frequency or cutoff frequency. So the frequency must be greater than the threshold frequency. In this way, energy per photon, energy of just one photon of the incident radiation will be greater than the work function of the metal. and we'll be able to eject electrons. Conditions for stimulating emission to take place. Stimulated emission requires the presence of a metastable state so as to reach a situation of population inversion. Conditions for Compton effect to take place. Well, Compton effect takes place when high energy photons such as X-ray photon or gamma ray photon collides with a very loosely bound electron. The electron is assumed to be free, and at rest the photon gives up only part of its energy to the electron. Explain. The action of the diode resembles that of a switch. Action of the diode resembles that of a switch. Okay, because the diode has a small resistance when it is forward biased and very high resistance when it is reverse biased. Explain. The transistor can be used as a binary device. Transistor can be used as binary device. Yes, since a transistor circuit can have two states, off and on, it can be used as a binary device. A binary system is a digital system based on only two digits, 0 and 1. Explain. At very low frequencies, the AC circuit, alternating current circuit, that contains a capacitor is regarded as an open circuit. It means no current flows. This happens when we have very low frequencies and the circuit contains capacitor. What about the capacitive reactance of the capacitor? Okay, XC equals 1 over 2 pi fc. So when the frequency is small, we've got an inverse relation between the reactance and the frequency. F is small, and this results in very huge, capacitive reactance. So the capacitive reactance increases when the frequency is decreased and almost no current flows in the circuit. Okay, explain. The hot wire emitter can measure both AC current and DC current. Why it can be used to measure AC and DC? Okay, because it is based on thermal effect. Function of the hot wire emitter depends on thermal effect of the current. And both AC and DC have thermal effect. Both AC current and DC current have thermal effect. So they can be measured by the hot wire emitter. In this way, we've come to the end of this edition. Until we meet again, my best wishes to you all. Thank you.